Hello, Algebra. Hope you guys are doing well. Today I'm coming live with 13.3, adding and subtracting expressions with common denominators. So that's going to be the key for today, is our denominators will be the same while we add and subtract these radical expressions. You might think, oh no, tomorrow they might be unlike denominator. Don't worry about that. We'll cross that bridge when we get there. Today, we're just going to kind of be going over it. And what's nice is these are a lot like fractions. So the steps for adding and subtracting fractions, you add or subtract the numerators. And of course, the denominators stay the same. Now, that should say add or, right? Those are, anyway, whatever. A couple things to keep in mind. We're going to combine like terms. So if our two different fractions both have an x squared, that becomes 2x squared, right? And when we subtract, we're going to distribute that negative sign all the way through. My example later this will make a lot of sense. But don't forget, like if you're subtracting a polynomial, a quadratic function, then you're going to subtract each of the terms individually, right? Okay. And then step 2, when we're adding and subtracting, you simplify the ratio. If you can, cancel out all your common factors, and then bada bing, bada boom. What you might need to do is you might need to factor your quadratics for simplification. You might need to do that. So keep an eye on that. I only have 3 examples today, guys. These are pretty short notes. I just heard Jake go, yay! Okay, here's my first one. 2x plus 9 over x minus 4 plus 3x plus 6 over x minus 4. So again, they have the same denominators. That's the first thing that matters. That is the title of our notes, so I didn't know if it was entirely necessary, but it is. They've got to have the same denominators for this to work out. Okay, so let's see. So first what I'm going to do is I'm going to combine them all into one ratio. So I'm combining my like terms, my x's with my x's. So again, I'm adding 2x plus 3x plus 9 plus 6. 2x plus 3x plus 9 plus 6 over x minus 4. Right, our denominator stays the same when we add fractions. Oh yeah, I think that's a sloth. Yeah, my happy little sloth. Okay, so that's going to give me 5x plus 15 over x minus 4. Now, I'm going to factor out this 5 on top. And what this does is it shows that this whole expression cannot be simplified any further. If you can, right, just recognize little things like this, little factors that you can remove or that you can extract, right? And doing that, it's like, yep, this is as simplified as this can be. If you left it like this, like this, you should factor it further. I might be a little lenient right now, but make sure that you factor it as much as you can. Okay, thank you. All right, moving on. Next example. This one we have 3x squared plus 8. Oh, I'm sorry, 3x squared plus 4x minus 8 over x plus 2 plus x squared minus 3x minus 6 over x plus 2. So again, they have the same denominators, x plus 2. And now I'm going to combine my like terms. Okay, so this one is a little bit longer. So I've got my x squareds with my x squareds. 3x squared plus x squared. I've got my x's with my x. So what I'm doing here is I'm keeping this sign. I know it's negative. So I'm adding a -3. Again, I'm doing this just for clarification. I'm keeping my life easy. And then I'm going to add -8, right? I've got -8 here, plus -6. Now, I know you guys are going to think, well, that's stupid. That's, why do I need to do something that's so unnecessary? Guys, I'm keeping it easy. I'm keeping it clear, keeping it nice and simplified. And of course, this has the same denominator. All of this business is over x plus 2. Okay, well, after I combine all this stuff, I get 4x squared plus x minus 14 over x plus 2. Is that my answer? No! All I've done is I've combined my like terms, but I haven't simplified. So what I need to do is I need to factor this to see if I could cancel anything out. Well, you might be able. So what I'm going to do is I'm doing my t-chart here. I've multiplied. I've multiplied 4 times -14. You get -56. And then I have +1 in the bottom, which gives me the factors of 8 and -7. Now, because my a term here is 4, I need to plug these bad boys back in. Here, I'm doing that AC method. So 4x squared plus 8x minus 7x minus 14. Then I'm factoring my two little terms. Getting that. Now, these two guys, x plus 2 and 4x minus 7, are my factors of this quadratic. So I've got 4x minus 7 times x plus 2 over x plus 2. Now I could cross these two guys out because they're being multiplied, so I can just divide, right? Division undoes it, leaving me with my answer, 4x minus 7. So this equals this. Pretty cool, huh? Yeah, cool, Mr. Bulger. I need, I haven't seen you guys, so I need to remind myself about all of your remarks and things like that. Anyway, okay, last example. I'm going to show you guys subtraction, and it's a doozy. Okay, well, now that we've got that done. Okay. So this is what we're starting with. They do have the same denominator. And again, I'm going to distribute my negative along the second numerator. So I'm going to distribute this to this term, and this term. Right? That's what I was talking about up here. All the way through. When we do fractions, we call this adding the opposite. So we would keep this, we would change this, and we would change this. What it's gonna look like is that, well, I'll just show you rather than tell you. Okay. So I've kind of kept it with its negative sign. But if you want, you can change this to positive and then negative, negative, negative. And then you would just be adding these as negatives. Whatever works best for you. You end up at the same place. 3x squared minus x squared plus 3x minus x minus 20 minus 4 all over x squared plus 9x plus 20. Okay, now this time I worked it vertically because, as you can imagine, there's a lot of factoring in our future. Okay, so after all of this, I get this, wow, that's a weird sideways triangle. Oh my goodness, that looks terrible. Don't look at it. Okay. 2x squared plus 2x minus 24 over x squared plus 9x plus 20. Okay, now what I've done from here is I have written out diamond problems. So for the one on top, I've got 2 times negative 24 is negative 48 over 2. And then for the one on bottom, I've got 20 on top and 9 on the bottom. Well, let's see. So what times what equals negative 48? That'll equal positive 2. So I know I'm going to have a negative. It's going to be the smaller number. And I know 8 times 6 equals 48. And they have a difference of 2 when they're positive. So bada bing, bada boom. And then for these guys, 4 times 5 equals 20, and add to make 9. Now, since this bottom one here has the a factor of positive 1, I know that that's going to be my denominator. Those are going to be my factors straight up. X plus 4, x plus 5, right? I did backwards, don't worry about it. But we need to plug these bad boys back in here to solve for the factors of the top. So I've got 2x squared plus 8x minus 6x minus 24. After I factor, so let's see, from this guy I could pull out a 2x, leaving x plus 4. And from this guy I could pull out a negative 6, leaving x plus 4. Easy money. So now these guys, 2x minus 6 and x plus 4, these guys are my factors. Ding, ding, ding. Those are my factors. Okay, so those go into my numerator here. 2x minus 6, x plus 4, x plus 5 times x plus 4. Again, I could cancel those bad boys out, leaving me with, again, I'm actually going to factor out a 2 from up here. So my answer is this. So, yep, it is a lot of work. However, it's not impossible, right? We're applying things that we've learned, that we've known for a while. If it feels overwhelming, just, well, remember it's Star Wars Day, so R2-D2's here for you guys. All right, I love you a bunch. I hope you guys are doing well. If you have any questions, please let me know. And otherwise, I'll talk to you Wednesday. Bye.